final year students, right? I think I'm correct. Final year or third year?
Actually, second year, sir.
Now your degree program, you have 2 years or 3 years?
3 years degree program. Now we are in second year.
Right. So, however, so this is some kind of course, cloud-based application development. This is some kind of course. It is relating to system engineering, and system administration. The domain of this subject is system administration, system engineering, and cloud technologies. And also there is a industry. There is a position called DevOps. This kind of area is relating to this kind of course. So this is, I think, all networking students and software students and multimedia all are participate in this course. This is some kind of common course for the faculty of IT. Okay. However, I think we are not much focusing on programming in this course, but what we are considering here is what is cloud and how we can use cloud for the software development. So that is the thing ultimately that we are going to cover throughout this course. Right, before starting, I will give some kind of introduction to myself, right? My name is ThariHasa. I am currently working at University of Colombo, Faculty of Technology as the Assistant Network Manager. So that is my current working place. I have few experience in industry and also now in some government organization. Previously, I am joined here. I was working at Sri Lanka Social Security Board as IT manager, and I have few experience with me. I'm pretty much interesting to share my knowledge and experience which I would having with me to improve your knowledge and also for your education and academic purpose. So I think let's move to some kind of introduction to this course. Right? What is this course is all about? Right. Module aims and objectives. This module introduces cloud computing with a strong emphasis on application development with the use of cloud solutions. Right. The main thing that we are going to discuss in this course is what is cloud computing. Introduction to the cloud computing. That is the main thing that we are going to study in this course. What is cloud computing and what are the environment behind the cloud computing, and actually what are the benefits and why we need cloud computing? This type of concept and some kind of environment and surrounding things around cloud computing we are going to discuss with a strong emphasis on application development, and we are going to discuss how this cloud computing can use for some kind of application development, software development. Right. This is the aim and the objective of this module or this course. If I went to the next slide, learning outcomes. What are the outcomes? Finally, after completing this course, what are the things that we are going to expect? Right? What are the knowledge or the knowledge gap we are going to fill? Or what are the skills you can obtain after completing this course? Right? Define cloud computing and its benefits. What is cloud computing? Why we need to use it? And its benefits. What are the benefits that we have in cloud computing? And the second one, classify cloud computing models. So what are the available cloud computing models? and how we can, what is the suitable model for our infrastructure if you are working in the industry or if you are working in some kind of organization, maybe government organization, maybe a lot of people are working with industries. So according to your organization domain and according to your organizational level or according to your organizational category, how we can define a model, a cloud computing model that is very much suitable for your organization. That is, we are going to study. And third one, identify cloud architecture and cloud operating system. Right? What are the architectures that we have available in cloud computing? What kind of operation architectures or designs that we can use for cloud computing? And also cloud operating system, especially for some kind of cloud infrastructure, right? Some kind of cloud infrastructure. You have to use some kind of cloud operating system to control and manage your cloud environment or cloud infrastructure. So for that, we are going to discuss about cloud operating system. And plan the application of virtualization and its design principles. What are the applications we have, and what are the virtualization? Right? We have a concept called virtualization. I think you may be familiar with virtualization. So in cloud computing, we are widely going to use virtualization and its design principles, how virtualization we can define, what are the development concept, and what are the principles that we can use for the virtualization, because we have different kind of virtualization concept and different kind of software tools we can use for the virtualization environment. So we are going to discuss these things, right? Before that, please put your name and your registration number, right? First your registration number, dash, and your name in the chat box, right? Then I can take the attendance, right? I think it is some kind of requirement for your department or the faculty. So please put your registration number and dash and your name. Name will be your initials and your last name, right? So please put that one in your chat box. That I can take I can download this as a document, and I can collect your attendance, right? I think we are in here, plan the application of virtualization and design principle. The next one, identify common security issues and solutions, right? When we are going to computing, not only cloud computing, right? When we are going to computing, do some kind of IT infrastructure development, networking, or some kind of software development, everywhere we have security issues, right? In computing. Also, it is common for this cloud computing. We have common issue for this, a common issue called security issues. We have everywhere security issues, and we have found some solutions for that security issues. Right? We are going to discuss what are the problems, what are the security problems we have in cloud environment, and what are the solutions that we can provide for this security issues or problems. Then develop virtual machines and virtualization with hands-on experience, right? I don't know this is how much practical to do some kind of hands-on experience. If we have some kind of lab environment with some kind of high-end personal computers, PCs, we can do some kind of hands-on experience or practicals. But however we try, if the country situation will be good, I think we can meet with the physical class and we can do some practical sessions on the laboratory. I don't know your university have a good laboratory or not, but if we have some kind of, we don't need server machines, but if we have some kind of PC machines, we can go with some kind of hand-on experience with this virtual machine and virtualization, right? We can do some practical session. Otherwise, I can do some kind of demonstration, some kind of demonstration. Normally, a laptop is not much good enough to run this virtual machine. If I run some kind of virtual machine inside the computer, then it is getting very slow. However, we try to at least do some demonstration of this virtual machines and virtualization. However, let's see, right? Right. Then outline syllabus. What is your syllabus that you have? Syllabus you have to study. Right. Cloud computing including benefits, challenges, and risk. Right? What are the benefits in cloud computing? What are the benefits that we have? What are the advantages and what are the benefits we can obtain through the cloud computing we are going to discuss. And challenges when we are going to implement this kind of infrastructure, cloud environment for maybe this cloud may be for the software development, maybe this cloud is for the some kind of video streaming, maybe email purposes, we don't know. According to the organizational requirement, we are going to implement this cloud environment. So then when we are installing or configuring or doing this introduction to this new technology, then we definitely occur some kind of challenges, right? We have to face and we have to mitigate and we have to overcome these challenges. And risk, what are the risks that we have, right? When in cloud computing, what are the risks that we have? Then in cloud computing models, right? We are going to discuss about some cloud computing models, including infrastructure, right? What are the infrastructure and what are the platform and what are the software, right? Infrastructure, platform, software as a service, right? We will discuss this, right? SaaS, right? Software as a service, SaaS, right? SaaS, we are calling it as SaaS, right? SaaS, software as a service, right? We are going to discuss this thing deeply, right? In future upcoming lessons. Also, this is some kind of example for this. I think you are using Google spreadsheet or Google Docs, right? This is some kind of example for this software as a service, right? We will discuss those, right? And what is a public cloud, right? We will discuss normally this Google environment. These are some kind of public clouds. And also we have some kind of private clouds. Organizations are some kind of organizations are maintaining private clouds. And also, this is the most populous method, hybrid cloud. A lot of organizations are using this kind of hybrid cloud infrastructures. They have both this public and private. So mixing both those things we are calling as hybrid clouds. So these companies are using this kind of hybrid models also, right? This is some kind of introduction. This private cloud is internal to the organization. This is some kind of cloud that is installed or managing inside the organization, and the whole hardware devices that is needed for this cloud will be available in the organization, inside the organization. So normally they have to maintain a server room or maybe some kind of data center inside the organization. And the public cloud. External users give access. Some kind of this public cloud means sometimes you don't have the infrastructure. That means you don't have servers, you don't have networking, you don't have some kind of internal storage devices, but you are using some kind of others devices, not your physical devices. There are popular service provided for these public clouds like AWS. You may hear these things, AWS, Amazon Web Services, right? They are supplying this kind of services, public clouds. And also there is Microsoft have this kind of cloud, public cloud called Azure, right? Microsoft Azure, right? Don't think about my spelling, right? Maybe that is not correct. Microsoft Azure, right? And also these are some kind of commercialized public cloud service providers in the world, right? And we have hybrid clouds. This is some kind of mixing of this private and public cloud, right? And integration of public and private clouds. Okay. Then next we are going to discuss about cloud OS and cloud architecture. Right, we will discuss about federated clouds. Right, what is a federated cloud? Right, and how we are going to scale the cloud environment. Scalability means normally simply think that you have in your computer you have 500 GB hard disk, right? Suddenly you need more storage. You need another 100 GB to come in totally as a 600 GB. But in a normal computer, we cannot do that logically, right? If we want to increase the storage, right, we have to, one thing is we have to add another hard disk, or another thing, we have to remove that hard disk and install a bigger one. Let's assume 500 GB hard disk you have to put 1 GB one, right? That is some kind of physical scalability. But in this cloud computing we are discussing about, without installing or can improve the storages, RAM devices, not only storages, right? RAM devices and the processing power, how we can improve or limit. That is what the basic concept of this is scalability, right? We will discuss, right? And performance, right? According to our requirement, right? We can adjust the performance of the cloud environment or our service provider, service that we are providing, right? Let's assume if that is a simple website, that is not normally, there is a website that for a day there is 10 visitors are coming, right? There's a website for a day, there is only 10 visitors. For our, let's assume that is our organizational website, only 10 users are normally coming, right? Then we can use very low performance web server for supplying that service. But let's assume if you have some kind of 10 million, right? 10 million users for your website, right? Then your web server, right? Web server may be must have some kind of harder bandwidth, right? That means you need to have better performance to supply this demand, this 10 million demand for a day, right? We will discuss this performance, right? Okay. Then next one, cloud OS. OS means operating system. What are the cloud OSs, right? And cloud architectures. What are the architectures that we have? Or we have to discuss, including federated clouds, right? What are the federated clouds, right? Scalability and performance, right? Okay, I think that is copying, right? Same thing, right? Okay. Then QoS, quality of service, right? QoS means quality of service. Again, scalability. We discussed about scalability, the property of a system to handle a growing amount of work by adding resources to the system. right? We are going to add resources to the system. However, maybe if we have physical storage, we are going to give new system or improve the system or adding new resources to the system using available resources, right? We will understand while we are discussing these topics, right? Just get some kind of idea in this, right? Okay. Right. And management of data traffic. What is data traffic, right? What is data traffic? How we can manage this traffic? Normally, normally you have bandwidth. The traffic means especially the bandwidth of the network, right? Right? How we can manage this traffic? We will going to discuss. And also data centers for cloud computing. Right? How we can design, what are the models or what are the things we have to consider when developing data centers for cloud computing. To store hardware, right, we have to maintain some kind of data center or maybe at least a server room. If you have a very less number of server machines to maintain for your cloud, then you have to maintain some kind of a small data server room. But if you have some kind of large infrastructure, like as example for the Facebook, right? They are using large data centers. They are calling there as a server farms, right? Facebook are using some kind of server farms for their services because they need a lot of storage for storing day-to-day videos, images, and the content that their users are uploading, right? So we will discuss about this data centers for cloud computing. Then next one is principles of virtualization platform. What is virtualization? What are the principles that we can use for the virtualization? Affinity and overcommitment, right? What is overcommitment? What is affinity, right? We will going to discuss those things, right? Right, and what is meaning of overcommitment, right? So those things we will discuss, right? And security and privacy issues in the cloud, right? Then we will discuss this security issues and privacy issues. What are the problems that we are occurring while we are going to discuss about this cloud environment or cloud infrastructure, right? Memory management for the resource allocation, right? How we can manage our memory, not only the physical memory, not only the hard disk memory, the memory in the physical memory, that means RAM storage memory, random access memory storage, how we can manage this memory, and also cache memory for the some kind of what is calling processors. For the processors, we need to manage the cloud memory that we are supplying for the processors. How we can manage this memory, all type of memories, how we are going to manage. Right? We are going to discuss those things in previous sessions. Right. And this is the prescribed text. What are the texts that we have? You can read. Right, Raphael Sarge 2020 Cloud Computing from beginning to end. Right, this is one textbook. There are two textbooks. I took these things from your syllabus. Right, the second one is Thomas ERL Cloud Computing Concept, Technology and Architecture. Right, I think I didn't found this book, right? But I found this one. I found some kind of public in website, public domain, but I don't know it is legal or illegal, right? Try to find these books. Maybe if you have some kind of library, in that library these books will be available. I'm not sure about this book, but this because this is a new book, 2020 book, so I think maybe it's not maybe available in your library. Maybe this book may be available. This is, I think I found the version of 2013 of this book. So I think if you search in the web, you can find this one, right? In public domains, you can download that one, but I don't sure whether it is legal or illegal because normally this is not a free book, right? This is some kind of commercial product. This book, right? However, if you can find, you can take this as a reference, right? You can read and understand this concept. It is a good book to use, right? Right. That is some kind of introduction to your course, right? Right. You have any question about this thing? What are the things that we had discussed? You can ask, right? Otherwise, I will move to the next presentation. Right. Right. I hope it's all clear to you, right? I hope you can hear me, right?
Yes, sir, we can hear you,
Right.
and no problems.
Yes, because that's why I am asking. Sometimes these connections are, it is disconnecting or some kind of problems can be occur. That's why if I am asking like that, you can say yes or hello. Yes, we can hear. That is enough for me, right? Okay. Then I will share this next one, right? Normally, because I am totally new to this your university, right? Unitech, right? So can I know that normally you are getting a break within the 2-hour lectures, 5-minute or 10-minute break?
No, sir, no need
No.
break, sir. We can do so.
It doesn't matter.
Right, but it is very difficult to conduct 2-hour continuous. So I am thinking to give some break, right? After 1 hour, I think that is okay, right? 5-minute break.
Okay, sir, sure, sure.
Refreshment.
Okay.
Kind of you can take out from the seat and you can have some kind of work. Maybe because normally I know when computer use it, now we are not in some kind of traditional classroom. So we are in front of the computers and normally you are sitting here and you are watching the closely thing. That means your computer is near to you. If you are inside a lecture hall, your eyes are focusing on books and also the lecturer or maybe the board that is available in the lecture room, right? Then it is good for your eye, your vision, right? But if you focusing long time period to your computer because it is very near to you, then you will have vision problems after few years of this if this is repeating. So normally when you are using, not only for these lectures, normally if you are computer person, you are some kind of computer people, IT guys, right? So normally when you are using, you can read this WHO instruction about this health guideline for the IT users, right? Then normally within half 30 minutes, half hour, right? 30 minutes, you need to look out from the computer and you need to look some long distances at a balanda, right? Because that is some kind of good exercise for your eye, right? Otherwise you will get some kind of problems like vision problems. Right? Because your eye is focusing to the near, right? So normally I think it is good practice.
Right.
Yeah.
And
Normally, yeah, it is better, right? If you, it is fine. You can if you are working inside the computer, it is fine. But you have to take the necessary health guidance or health recommendations, right? Then you can be with healthy, right? Normally, then try to take some kind of that kind of exercise, right? Product kela langa balang hitiyot me ata pena එක නැති වෙනවා. මොකද ඇහැට ළඟමනේ බලන් ඉන්නේ, right? That kind of problems that is available, right? So I will give a small break, right? Within 1 hour, and we will start within another 5 minutes, or you can have some water or something, right? Also, I can have a break because you are normally listening, right? I am talking, right? I am talking, so it is not easy as you think, right? Right. Okay, we are going to discuss. I think you can see my screen. This is we are going to do some kind of overview, right? Overview to the cloud computing. Right? Okay, right. Firstly, I am going for the introduction. Right? The ACM, right? ACM computing curricula 2005 defined computing as, right? So what is this meaning of this ACM mean, right? Association for Computing Machinery. There is some kind of organization, some kind of association, right? The acronym is all about Association for Computer Machinery, right? Computing Curricula 2005. They are developing some kind of guidelines for the curriculum development, right, of the computing, right? The ACM Computing Curricula 2005 define computing as, in a general way, we can define computing to mean any goal-oriented activity requiring benefit from or creating computers, right? Computing to mean any goal-oriented activity requiring benefit from or creating computers. Using computers, if we can do some kind of work or some kind of benefit, right, or some kind of goal using computer, that is defined as computing, right? Thus, computing includes design and building hardware. This computing including designing and building hardware. It is also including hardware and software also. Computing means we have both software and hardware systems for wide range of purposes. These hardwares and also this deal of softwares, we are using wide range of purposes, right? Wide ranges of purposes we are using this software and hardware, like processing, structuring, right? For the processing and structuring and managing, right? And managing various kind of information, right? We can use for data processing, different kind of data processing and different kind of structuring, right? We can store with some kind of data structure, right? If you assume that if you have a shop, let's assume silver badukadya, right? A shop, right? You have to store your shop data or shop items in some kind of database, right? Then you have to structure. These are the items of liquid. These are the soap categories, right? These are the, what else you have? These are some kind of vegetables. Likewise, you have to store this information, right? For storing this, you have to structure this information. Likewise, the categories like vegetables, meals, those wise, right? And managing various kind of information, right? And managing various kind of information, right? You have to manage various kind of information doing scientific studies, right? Normally in scientific studies, in research, right? Some kind of innovations, right? Using computers, right? For the scientific purpose, they are using computers, right? That's why in early time, like in Newton's time, Albert Einstein time, the technology was developed slowly, right? Technology was developed slowly, but now you know how fast it is developing, right? Mobile phones and some kind of, let's assume mobile phones and laptops, how much fastly, especially the mobile phone, it is developing, right? The main reason for this development is this computing and computers, right? The researchers are doing their findings fastly using the computers, right? So that is some kind of story behind this fast and rapid development of this science. Right? Right. Making computer systems behave intelligently, right? Behave intelligently. You know, artificial intelligence, right? Now computers, normally some kind of machines are now working intelligently, right? Not if you ask them to, let's assume you are refrigerator in home, right? Normally, let's assume if you turn on it, right, after coming to the certain temperature, let's assume 5 Celsius, after coming to the 5 Celsius, the system will be shut down or in sleep mode, right? It is not continuously running, right? So these devices have some kind of intelligence, right? They know now the temperature is 5%. I need to turn off my machine, refrigerator machine, fridge machine, right? Right? So they have some kind of intelligence, right? This is some kind of a computing system, right? Right? This is some kind of computing system. They have intelligence. They know now I want to stop. They are taking this decision individually, right? That is what we are called this making computer system have intelligence, right? They have some kind of intelligence, right? Right. Normally, I take the refrigerator as an example, but in computer systems we have, right? They know I need to stop now, right? Now these modern computer systems have this intelligence. The advanced concept of this intelligence we are calling as artificial intelligence, right? Then creating and using communications and entertainment media is all the things we are doing for the happiness, right? Finally, for the happiness. If you are like studying, maybe your target may be doing a good job, right? Or maybe you are just studying for the happiness, right? Some students I know they are studying for the entertainment, right? A lot of students will not be accepted, but some students are entertaining their education, right? They like to study, right? So likewise, creating and using communication and entertainment media. Normally with this computing also we are using for the entertainment purposes. Normally, you know, in Sri Lanka now, Sri Lankan film industry, right? Now there is a very little film industry in Sri Lanka because why? The development of the popularity of these laptops and computing devices inside the home. Now they are watching films using this kind of devices. They are not went to film halls. Now film halls are available, right? Film halls are, right? There is no customers, right? I have, if I could have time, I can say that story. I will tell that story, right? Another day, because I went to see some film, right? What was my experience, right? That kind of disaster in the filming industry, right? Because people are using home held devices and some kind of mobile phones even to watch movies, right? They are not going to film halls, right? So we are using this computer system for the entertainment as an entertainment media, finding and gathering information. Now people, if they have anything, they are searching on Google, right? Gathering information, right? If they want to see anything, right? We are searching now Google, right? That is obvious for me also, right? If I have something don't know, we are normally Google it, right? Just say, hey man, please Google it, right? That is normal thing, right? So we are using computing for the gathering information, right? I will come to a certain question after this introduction, right? I will ask some question, right? A simple question, right? So I just remembered that I just now thought to ask that question, right? Right. Finding and gather information relevant to any particular purpose, right? Number of reasons, right? Now, if you want to learn, if you want to know about your favorite film actress or film actor, you can find that information, right? If you want to learn something, you can use internet, right? This computer and so on, right? The list is virtually endless, right? This list will be endless, right? And the possibility are the vast, right? There are a number of possibilities also available, right? Okay, trends in computing. That is some kind of, here this is the introduction to this computing, right? And let's see the trends in computing, right? Before I will discuss this slide, I will ask that question that I could remember, right? Right. Please answer this question, right? This is a very simple question. Is anyone in this class are using cloud computing now? Currently, is there anyone in this class, in this lecture, using cloud computing currently? Is there anyone? Right? Is there anyone? Right? Some messages, I think, yes. Right? Yes, there's one yes, right? One message is yes. Right. Okay, only one, I think. Is my audio is not clear? There's a message. I saw that one, that message now. Is it not clear? Right, fine, it's clear.
Clear, it's
Sorry?
voice එක clear ඇහෙනවා sir, it sound එක අඩු වෙනවා වැඩි වෙනවා.
Right. That is the thing, right? But you can continuously hear, right?
Yes sir, yes.
That means some kind of connection issue, I think, right? Maybe. Right, let's see. Right, there is one reply from you. There is 1 years, right? There is 1 years. Right, then another question. After that question, right? Does anyone using email for their day-to-day works? Let's assume Gmail, Google Mail. Is there anyone using Gmail? Right? There is only 1 yes again, right?
Yes,
Yes, okay, fine. I know, right? Okay. I know you are using email, right? I know you are using email. So what I want to tell is, right? Some people, some students are not sure that they are using cloud computing or not, right? Some students are not sure that they are using cloud computing or not. But I know every one of you are using Gmail. Right? Each one of you are using Gmail, right? I want to say that Gmail is a cloud-based email system, right? Email management or email system, email service, right? So I think all of you are using cloud computing, right? All of you, that means you are using Gmail, that means all of you are using cloud computing, right? That is the idea. Right, someone is turning on the mic. Okay. Right, okay. Right, the Google is some kind of, I want to say, Gmail is a cloud-based email service. That is most, I think, also this Google search engine, also a cloud-based search engine, right? It is using cloud environment, right? It is using cloud infrastructures, right? So that is the idea, right? That is the idea. And also YouTube. YouTube is also cloud-based video sharing system, right? Cloud-based video streaming service, right? So if you are not known, but you are using these cloud services, right? You are not thinking, but you are using these cloud services vastly, right? Today, a lot of services are cloud-based services. Normally, the lot of websites today available, those lot of websites are using cloud services, cloud popular public cloud platforms for supplying this kind of services, right? Okay. Then trends in computing. What are the trends that we have in computing? Right. I think these words, these wordings may be familiar to you, but maybe you don't have clear idea, right? Distributed computing, grid computing, right? Maybe you haven't heard what is, I think there is a word or there is a concept called distributed computing, right? Maybe, but you don't have some kind of good idea, right? Then grid computing, right? What is grid computing and what is all about, right? Maybe you may heard this word, right? And cluster computing, right? And utility computing, right? These are some kind of trends, right? Some kind of trends in computing, right? Cluster computing, utility computing, and also cloud computing, right? To understand this cloud computing concept in a broader way, right? You need to first identify this concept. This distributed computing, what is grid computing? Likewise, you need to have some kind of, not a large idea, right? Some kind of simple or maybe introductory idea about these topics to understand this cloud computing. So before going for this cloud computing, I will give a brief introduction to this distributed computing, grid computing, cluster computing, and utility computing, right? So then it is very much easier you to move with cloud computing concepts, right? Then first topic is this one, distributed computing, right? Distributed computing, right? Okay, let's see. Centralized was distributed computing, right? Right? Early computing was performed on single processor, right? Early computing was performed on single processor, right? Uniprocessor computing can be called centralized computing, right? Let's take the idea, all right? In this picture, it is notated name as mainframe computer, but however, right, some student is telling that Zoom is example for cloud computing, right? That is all. Yes, that is some kind of Zoom cloud environment. This is some kind of Zoom servers are running behind this one, right? So this is also there's a question, right? Zoom is that the student is asking about that. Zoom is also a cloud service. Yes, that is correct, right? Okay, we will discuss about this image, right? Mainframe computer, right? Normally, this is what we are calling as a centralized computing. That means there is a single computer, or maybe this may be a normal PC machine. Lot of time, this is some kind of server machine, right? Mainframe is some kind of category of server, right? Mainframe, supercomputers, these kind of are some kind of computer, right? This is some kind of server machine or mainframe, maybe a supercomputer, right? So this supercomputer is giving services, other terminals, right? These terminals, that mean users. Normally, these are some kind of PC, maybe you, right? These are PCs, right? Maybe you. Let's assume this is Facebook, right? This is inside Facebook, right? We will take this as your, I think you have LMS, right? I don't know if you have, do you have LMS, Learning Management System in your university? Can anyone say yes or no?
Yes, sir.
Yes, right? So let's take your LMS, right? This is, let's assume this is your LMS, right? LMS, right? LMS, Learning Management System, right? LMS. And this is you, your PC, your laptop, or your phone, or something, right? So you have in your university, in your server room or your data center in the university, that this LMS server will be available, right? Then what you are doing, using various devices like computers, mobile phones, maybe tab, whatever the device, you are connecting to this server, right? So this is one server available for this LMS, ULMS. There is one server. You all are connecting to that server, right? You all. This connecting medium will be different, right? Maybe it is USLT connectivity network, maybe dialogue, whatever, right? Some kind of Wi-Fi connectivity, maybe your university Wi-Fi network, right? Whatever the things, right? What we are discussing here, right? All we are connecting to this server, right? So this is the idea about this centralized computing, right? Okay, that is the total idea, right? You have this is networking, right? This line means you need to use some kind of networking technology or networking devices for connecting for this LMS, right? And next one is the distributed computing. What is the distributed computing mean? Right? In here you have one LMS. That means one server, one LMS. Right? In here also, right? You have one LMS. That is obvious, right? You have one LMS, right? You have one LMS, right? But you have different servers, right? You not only one server. You have different or few server machines or few supercomputers or few mainframes, right? That is what we calling as distributed computing, right? So this every server machine is supplying this LMS service, right? This is some kind of example for the distributed LMS, right? This is a distributed LMS. In this example, it is distributed within three server machines, right? It is distributed within 3 server machines. And to the host, anyone can join for any server, right? Then they can take this LMS service. If there is any other machine, right, they can join to this server machine, right? Any client, right? Or workstation or something. Workstation means user, right? They can join, right? If there is anyone, right, he can join to this one, or he don't like, he can join to this one also, right? Anyway, right? So this is the main idea about this centralized computing and distributed computing, right? Okay, there is some message for me, right? I will check that one, right? Right, there is
Excuse me, sir.
Yeah.
So is that mean we know Google Workspace system, Google Workspace system like as the distributed computing system?
Definitely in Google infrastructure, right? They are using some kind of distributed infrastructure, distributed computing infrastructure they are using, because they have not only one server farm, right? They have different server farms and different servers for different purposes, right? So normally for the normally for the Gmail service, they have separate servers, not only one server, right? Not only one mainframe, right? They have large server farms dedicated for the Gmail service. Likewise, for the separate systems, they have separate kind of infrastructure and this kind of network and server farms, right? So definitely, according to your answer is for your question is yes, right? They are using this kind of distributed computing, right? Also, if we are taking AWS, right, Amazon Web Services, right, they have their server stations all around the world, right? All around the world. They have server center in Mumbai. They have one in Australia, as if I correct, Australia, and also in Singapore. They have America, North America, South America, they have a lot of server farms for supplying these services, right? Normally, if we are taking services, normally we are using Mumbai, Indian servers or normally Singapore servers because they are the most closest, nearest servers for us, Sri Lanka. That's why we are using this AWS, this kind of services, right? So that is the idea, right? Then I think I had answers to your question. And then there's another question to the chat box, right? Sir, do we have cloud-based practical in this module using some vendors like Amazon or AWS, Citrix, or is this focus on these theories, right? But whatever the thing here is, right? If your university have some kind of this kind of accounts, AWS accounts and Citrix, right? Citrix server environment that we can run, then we can do focus on practicals. But I don't think any university in the country having this kind of infrastructures, right? Any kind of university, this kind of Citrix environment for the education purpose. Normally in universities for their services, in their server room or maybe in their data center, they are using this kind of infrastructures. But normally for the academic purpose, for the teaching purpose, I don't think they have set up this kind of Azure and AWS because especially we know normally the universities are not using AWS, Amazon Web Services or Azure for their internal works also because for we have procurement issues, right? Normally I know this scenario, right? Because this AWS don't have Amazon Web Services, right? Don't have steady payment, right? According to the system or the resources we are using, we have to pay. The idea is month by month, we have to pay different payment according to the usage, right? Right. Normally that is a problem for using these cloud services in university system. I don't think for the academic, for the teaching purposes, there is accounts for the AWS or Azure, right? Normally, now my organization, that is University of Colombo, we are not using AWS or Azure, but when I was in the industry, we are using, right? So I think if we have to go some kind of practicals in this Azure or AWS or Citrix, if we have this kind of facilities in your university, we can go, because if we are going for this practical, you need to have these accounts. Otherwise, I am showing something and you are seeing this thing, that is not enough. I will show some things, right? Some basic things, but I don't think there is a facilities in your universities to conduct this practicals. Normally, as my experience, we learn these things in the university, but the actual practices or the real world using was done in your intern period, in my intern period. Normally, I think you have an intern period in your university, 6-month internship in some kind of organization. So that is the most valuable part in this your degree program, right? You can learn a lot of real world situations and hands-on experience in what you have learned throughout the 2 years or 3 years or 4 years. Then you have this all theories come to practical, right? So if we have a chance, that kind of chance, we will conduct some kind of practical sessions, but I'm not sure, right? I'm not sure about that one, right? Okay, I think I answered that question.
So අපිට මේ free trial set එකක් set කරගත්තොත් මාසයකට විතර මේ පුළුවන් නේ කියන්නේ අර මේ cloud based යාලගේ දෙනවනේ free trial එකක් දැන් හැම එකෙම වගේ ඒ වුණොත් මාසයක් විතර මාසයකට අපිට free trial කරන් අපි schedule එකක් දාගත්තොත් අපිට මොන හරි practical එකක් කරන්න පුළුවන් වෙන්නේ සර්.
I think for that one we have to give some kind of credit card detail or something, right?
Yeah.
Am I correct?
Yes.
I don't know if it is visible to you. Right, let's see, right? At least one session, neither. If it is possible, let's try. Let's try, right? Okay. Right.
Sir, मैं මෙතන sir මේ දැන් අපි මේ centralized computer එකේදී අපි මේ මෙතන terminal කියලා පාවිච්චි කරලා අපේ PCs වලට එතකොට ඊට පස්සේ මේ distributors computers සහ අනිත් ඒවාද මේ workstation කියලා පාවිච්චි කරන්නේ මේක මේ terminology එකක්ද තියෙන්නේ. ඒ කියන්නේ මේ centralized computing කියන concept එක ඇතුලේ තියෙන terminology එකක්ද terminal කියන්නේ. එහෙම නැත්නම් අපිට මෙතන workstation එකම පාවිච්චි කරන්න පුළුවන්ද?
Actually, right? Don't much think about this term, right? This terminal means the PC, right? Also, this workstation means the PC or any kind of devices, right? Any kind of devices, right? We can use this both word. Terminal kineka ganna puluwan, workstation. If you want, you can put computer, right? Or your mobile phone. That is not problem, right? Don't much think about this terminal and workstation, right? Right. This is also networking, right? Here it is not noted, but here not noted, right?
So මේ මෙතන එතකොට distributed computing කියන එක mean කරන්නේ මේ redundancy කියන concept එකද මෙතන?
Not only redundancy, availability, and also what else? Redundancy, availability, speed,
integrity,
all those things, right? All those things. Right. Okay. Let's move, right? Then distributed computing systems. Right. We are discussing, right, about this distributed, right? Distributed computing. Right. I think what is the time that we had started? 4:45, right? Am I correct? Yeah, right. Around 5:45 we started. Right. I think we will take 5-minute break, right? Now it is 5:50. Right. I will start at 5:55, right? After some kind of little break, right? Is it okay?
Okay, sir.
Okay, 5:55, I will start, right? Right, are you full-time students or you are part-timers? Or you are working in some kind of organizations?
No, sir, we are full-time student.
You are full-time and you are working?
No, sir, no.
No, you are staying at the university, right?
Yes, sir.
You have uni life, right?
Yes, sir.
Okay, fine, that is fine. Because I know if you are a full-time student, only you have uni life, but otherwise that is the very tough situation, right? Okay. Then I have another message that I will take that one. So is AWS like Google Cloud Service? These are same. No, sir. Right. Right. Google Cloud Service. Yes. Google Cloud mean like if you mean that what is that email, Gmail or YouTube? What is that Google? What is spreadsheet or Google Docs, Google Slide? This cloud service mean, right, actually Google is supplying servers. If I want to purchase a server machine, right, Google Cloud, that means Google Azure service will give me server machine for me and public IP address, right? That is what we are discussing. Also this cloud service mean AWS also that kind of services. If you have a server to run a website with Ubuntu operating system, right, or CentOS operating system, so we can hire within some payment. We can hire, right? That is what is called AWS, Amazon Web Services. Google Azure is that kind of service, and this Google what is normally you are using this Google environment, this Google Docs, and those things are some kind of applications. We call it as SaaS, software as a service. These are SaaS services supplied by Google, right? Okay, that is the idea. Right. Then let's move to the lesson, right, actually. right? Distributed computing, field of computing science that studies distributed system, right? It's some kind of field in computer science, right? It is in computer science, right? Computer science. The computer science is a subpart of physics, right? Physics, you know, physics, right? Physics, right? Physics. This computer science is, according to my idea, right? A lot of people have different ideas, but according to my idea, right? Maybe some professors or some others maybe have different idea, right? Some others are telling this is a combinations of physics, chemistry, and lot of things. But yes, we cannot separate anything. But according to my idea, and the lot of component are mostly related with the physics, right? Computer science is physics. So this cloud computing also, right? And also this distributed computing also part of this computing science, that means physics finally, right? So use of distributed system to solve computational problems, right? We can use some kind of computational problem, right? What are the computational problems mean, right? Use of distributed systems or computational problems. Let's assume, right? You are a hacker, right? You are a hacker, right? You are a hacker, right? 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 You want to break your friend's Facebook account password, right? You want to break, right? It's not easy, right? It is not easy. There are different type of methods you can try, right? Maybe not successful, right? You can try, but if you are going to find this password computationally, you are going to find this password computationally. It is a computation. We are telling it as it is computationally large problem, computationally big problem. To solve this problem, to find this password, you need huge computing power. You need huge computing power. To supply or to gain this huge computing power, you can use this distributed system to gain that computing power, right? Right? That is the idea, right? That is the idea. Okay. Then we are going to some kind of explanations or the definitions, right? The Wikipedia, right? There are several autonomous computational entities, each of which has its own local memory, right? In this distributed computing, they are telling they have this local memory, right? The entities communicate with each other by message passing, right? Right. We have a lot of entities like this, 1, 2, 3. We have few entities with its own local memory. It's have a local memory, right? We have a processor for the processing, and it's have its own memory, right? This memory mean RAM, right? Here this memory mean RAM, right? Also hard disk also we can consider, but here it is not noted, right? Mainly a computer mean a processor and a RAM. If something we have with the computer, that means, if the processor and memory, we can denote or we can note that one as a computer, right? No need a laptop or desktop machine, right? If anything, right? Even your Android mobile phone is a computer, right? Some kind of, it is doing computations, right? Several autonomous computational entities, each of which has its own local memory and local processor. The entity communicate with each other by message passing. Here is one entity, 2, 3. They are communicating with each other by message passing. There is some kind of protocols for this message passing paradigms, right? You have some kind of protocols, right? they are communicating. We will not going to discuss deeply about this message passing algorithms or any other things. I think it is the concept you can discuss in, I think, what is data algorithm and structures, maybe functions, or maybe, right? Or data communication, you can discuss this message passing algorithms, but I am not going to discuss those things. What we are going to learn is we can use this message passing technologies or algorithms or protocols for this communication, right? This communication, right? Here also communication, right? Then operating system concept, distributed system, right? The processor communicate with one another through various communication lines, right? Such as high-speed buses or telephone lines. Right? Each processor has its own local memory, right? Maybe, right? You have a computer, right? You have a computer with a lot of processors, right? Lot of processors, and lot of memories, right? These are memories. 1, 2, another one is 3, right? Lot of memories, right? This is also some kind of distributed system inside a single computer, right? That is the idea here. The process communicate with one another through various communication lines, right? For communicating these devices, they are using different communication lines, right? Here, this one may be here, and this one use this line, right? Right. For the communication purpose, right? This is operating system concept, right? Because inside one operating system, you have this kind of multiple distributed system, right? And deeply, we are calling this kind of system as parallel computing, right? We will not much discussing about parallel computing here, but we will give some kind of introduction to parallel computing, right? So the parallel computing is a part of this distributed computing, right? Okay. Each processor has its own local memory, right? It has its own local memory, right? Connected to it, right? That is the idea. Then example, distributed systems. Example, distributed system. First one is internet, obvious, right? It is some kind of distributed system. Number of server farms are there, maybe single servers, right? Normally, large companies using their own data server centers or data storage stations. Maybe large companies that is like AWS or Google providing cloud services, right? So this all through the internet, right? The AWS and Google Azure, right? AWS and Google Azure, right? Also, these both are supplied to the internet, right? This AWS service, Azure, all are given, all are supplied to this internet, right? All are supplied to this internet, right? That is the way, right? And also ATM bank machines, right? ATM and bank machines, right? This is some kind of example for the distributed system, right? Okay. Then intranet and work groups. I think you know what is intranet, right? Intranet, right? Intranet is, I think, internal network, you know, inside an organization. I am in Faculty of Technology, University of Colombo. Inside our faculty, there is an intranet, internal network, right? Internal network for the Wi-Fi, maybe also CCTV camera, IP-based CCTV camera. We can use some kind of network, internet, intranet, right? And CCTV camera, and also Wi-Fi access point, LAN ports. So infrastructure, if you are using intercom, right? Internal phone system, telephone system, intercom, we are telling it as intercom. You can use this internal network. That internal network that is limited to some kind of organization, we are telling as intranet, right? That is what we are calling as intranet. And work groups also, the same concept, right? Same concept. Inside some kind of intranet, we can create some kind of work group. We can share the resources, we can share the server machine, right? Likewise, we can do. Computing landscape will soon consist of ubiquitous, right, network connected devices, right? Consist of ubiquitous network connected devices, right? Maybe in your intranet or maybe your infrastructure, there is having number of different type of, right? Different type of network connected devices, right? Maybe mobile phones, we have any other, right? Mobile phones, telephones, maybe Wi-Fi access points, maybe some kind of sensors. You know, in some organizations have LED bulbs that is working in night with sensors. That is some kind of IoT technology, Internet of Things technology, right? And also we cannot measure the limitation, right? Maybe some instrument, actually not this computing devices, some instrument also have some instrument. Some normally universities have some kind of machines, what is called some kind of lathe machines, new 3D printers, right? This kind of devices also come into network. Also printers, right? Especially not 3D printers, normal printers. They are also in the network normally today. All are network connected devices, right? That is what we call as some kind of example for the distributed system, right? Right. Computers in a distributed system, right? This is some kind of name, right? I will explain simply, right? Workstations, computers used by end users. Some students had asked this problem here, right? This workstation and terminal, right? This is same, right? Also here it is explaining workstation mean computer used by end users. Not only computer mean any device, right? Mobile phone, anything, right? Mobile phone, computer, laptop, what else, tab, anything, right? And maybe some kind of any other device, right? Computers used by end users to perform computing, right? That is what we are meaning as, what is the meaning of workstations. Then server system. Computers which provide resources and services. This is some kind of terminology, right? Server system. Computers which provide resources and services. This is some kind of devices or the computing device that is giving services. Maybe serving. Server means that this is serving something, right? Serve karna again, they are serving something to us. Like that, these web servers are serving website for us. They are holding the website, they are serving us, serving it to us. Right? That is the service. And also some LMS, they have LMS, they are serving it to us to use. Please use this service. They are serving it. That is the meaning of the server, right? That is not a different word, right? It is serving, right? Servers are serving some kind of services. Also, Google services are giving YouTube to us, right? That is some kind of video streaming service, right? Okay. Computers which provide resources and services. Right? That is the simple idea of server. The supercomputer or the mainframe computer, right? Supercomputer, right? Supercomputer or some kind of mainframe computer. Mainframe computer means, right? This is some kind of combination, right? Combination of servers, right? Supercomputer means not a single server, right? Supercomputer means a combination. Also, this mainframe means some kind of combination, right? Supercomputer is higher than this mainframe, right? These are supercomputer means a collection of servers, right? And also mainframe is a collection of servers, right? So we can tell this supercomputer as a server system, right? It's some kind of server system, right? Computers which provide resources and services. Also resources, we can use this kind of computers for storage purpose also. There is a special devices called SAN, right? SAN means storage area network, right? SAN. And also another device called NAS, right? Right. These both are used for storing data. If you have huge data, huge bulk of data, we can connect some kind of SAN infrastructure, SAN devices. This is huge storage, right? Maybe terabytes, right? Not megabyte, not terabyte, right? Thousands of terabytes, right? Right? This kind of storage, right? Normally it is having from 20 terabyte to upward, right? Or maybe in Google and Microsoft, right? They are using, right, petabytes kind of storages, right, for their purposes. So wait, right? Give me 1 minute. Right. Personal assistant devices, handheld computers connected to the system via wireless communication, right? Normally, personal assistant devices, we call it is some kind of old name, PADs, right? Personal assistant devices. Normally, this is some kind of name for the handheld devices like mobile phones, some kind of wireless, mainly the wireless communication devices. Normally IoT devices also, some people are, these are some kind of terminologies, and some people are telling this is also personal assistant devices. So some kind of IoT devices also, some people are denoted as personal assistant devices. Right, so these some kind of terminologies: workstation, server systems, and personal assistant devices, PADs, right? Right. These are, then I think you have some kind of idea about what is distributed computing. And this is some kind of common properties of distributed computing, right? Common properties of distributed computing. First one is fault tolerance. Fault tolerance. What is fault tolerance mean? Then when one node fails, right? We discuss about, right? Here, right? This is some kind of distributed system. We can denote this as a node, right? Right? Node. This is node 2, this is node 1, and this is node 3, right? Then we have 3 nodes here. For this example, we have 3 nodes, right? Then when one or some node fails, what happens is one node fails when whole system can still work fine. If one node is failed, the whole system can still work fine except performance, right? What happens if there is this one node is, let's assume it is faulty, it is not working, it's not servicing, but this we discuss about LMS now, but still, if one node is failed, but still this LMS available, why? This node 2 and 3 are still up and they are supplying the services, right? One is not working, but 2 and 3 are supplying the services. Then due to that reason, LMS is working, right? So that is some kind of advantages of this distributed computing. But if you think the centralized system, there is no any node, there is one node here, right? If this mainframe computer, this server is failed, total the LMS will be not available, or we are telling technically it is LMS was down, right? Right? So that is the idea here, right? That is the idea here in this fault tolerance, right? When some nodes fail, the whole system can still work. Whole system can still work fine except performance. But earlier the performance will be degraded. The performance will be degraded because earlier there was 3 nodes servicing to the users, but now it is have only 2 servers. Then the performance will be getting down, right? Performance will be getting down because of this one node down, right? So that is what we are discussing about this fault tolerance, right? Need to check the status of each node, right? Normally, if you are maintaining or giving services through some kind of distributed computer system, so you need to give a clear attention. Normally, if you are maintaining some kind of server infrastructure, a critical, I want to mention that one, right? Normally, if you are maintaining some kind of critical server infrastructure, you need to have 24-hour service roster for the working people. What they need to do, they need to check the status of each server station or each server. They need to check the status. Otherwise, if there is two system was down, it is working. One node is down, it is working. But what happens if two node is down? Then the system will be still available with this third node, but the system will be very slow. You need to take immediate action to restore these two and first nodes, right? For that one, continuous monitoring in this kind of infrastructure is much needed and recommended, right? That is the idea. Right. Each node play a partial role. Maybe it is not a complete role. When the whole system is totally working, they have three nodes, right? Three nodes, right? One, two, three, right? Just assume these are three nodes, right? This is let's assume 1, 2, and 3, right? Each node play partial role, right? Not they are dividing their work, right? Each computer has only a limited, incomplete view of the system, right? Right. Then there was some kind of message for me, right? Okay. Then what happened? I was discussing about incomplete view of the system. This node is not completely known about the total system, right? But it is limited. It is enough. It is liable, or can run some kind of downtime of this, some kind of node. It can handle, but it don't have the whole idea about the system, right? That is the idea here, right? That is the each node play a partial role, right? Each computer may know only one part of the input, right? They know their part, right? Like garments factories in Sri Lanka. That is a fabric. They are making some kind of clothes. There is lines for making clothes, right? Weaving clothes, right? Then first girl only know to weave the pocket, right? Second one lady know only to weave the button, like that, right? In this kind of infrastructure, right? That is same here, but that is not same here. But this single node don't have complete total idea about this complete three-node system, but it has idea to run this system. If some node fail, it can run, but it don't have total idea. That is the case here. This is one properties of this distributed computing. Then resource sharing, right? Each user can share the computing power and storage resources in the system with other users, right? Each user can share the computing power and storage resources, right? Resource sharing, very popular concept, right? Each user can share the computing power and storage. This node has 500 GB. This one 500, this one 500. They are using these resources sharing, right? If they want to store some storage here, let's say the storage is here all, he will use this second node storage. Likewise, these distributed systems are working. That is what we are calling as storage sharing, right? And computing power. Right? Let's assume this node have 1,000 computation to handle. Right? Then another computation is coming, 1,001. 1,001 computation. Then what this node can do, he is not going to take that computation. He will pass that computation to the second node. Right? He will pass this computation to the second node. Then what here happening? This is what we are calling as computing power resource sharing. Right? Right? Then this one will be handle that request for that process because this one is busy. Right? That is the idea about this resource, this power and storage resource sharing. Right? Then load sharing. Right? Dispatching several tasks to each nodes can help share loading to the whole system. Right? Dispatching several tasks to each node. Right? This is some kind of interesting idea, right? Some kind of interesting idea. They said, this is the work, right? This is some kind of work that you have to perform, right? Right? I will divide this work, right? 1, 2, 3, 4, 5 parts, right? This is work 1, right? W1 mean work 1, right? What is load sharing mean? This is one work, right? One work. Normally in normal computing, this one work is totally handled by some kind of single processor and memory. What we can do in the distributed computing, is this work one is divided to 5 chunks, 5 parts, and each part sent to different nodes in the distributed system. Let's assume this one and this one sent to the node 1. Second, third will send to the node 2. Fifth one will send to the node 3. Likewise, this load can be shared. Right? Load can be shared. That is the idea about this load sharing. Dispatching several tasks to each node can help share load into the whole system. Then, easy to expand. We expect to use few times, right? We expect to use few times when adding nodes. How to spend no time if possible, right? This is 1, 2, and 3 node. If we want to expand this computing power and the storage and maybe some kind of thing, right? What we can do, we can add another node, right? Simply, there is a little bit, very few configuration within few configurations. If we have this kind of physical devices, we can include this one into this distributed system, right? Then there will be 4 nodes. Then, if we want, we can add another few, 5, 6, 7, like that, right? So that is what we call as easy to expand. Right? Then the performance. Parallel computing can be considered as a subset of distributed computing. Right? Parallel computing can be considered a subset of distributed computing. I also noted this thing earlier. This inside this distributed computing, the parallel computing is available. Right? Normally, there is some kind of university courses that is available called parallel and distributed computing. Parallel and distributed computing. Normally in parallel computing, in parallel computing, GPUs, right? GPU, graphical processing unit, graphic card again, right? In GPUs, graphical processing unit, there is number of, inside that there is number of processors, right? Right? Number of processors, right? Maybe we have, normally in a lot of infrastructure, we have 8 processors, we call it as cores, right? 8 cores, 16 cores, 32 cores, GPUs, right? In this GPUs, they are using parallel computing, right? Normally in NVIDIA, NVIDIA graphic cards, we can do this parallel programming, right? this is not a programming course, right? This is not a programming course, but this is system engineering course. But I will give this idea to you. This GPU, there is a, in this GPU, NVIDIA, GeForce graphic cards, there is a software to program this parallel computing, right? I cannot remember the name, right? However, there is some kind of software packages to program this GPUs, right? Graphical processing units. You can program in this GPUs. We call it as, yes, CUDA programming. We call this as a CUDA programming because in this NVIDIA GPUs, we call, we are telling this Go as a CUDA code, right? CUDA code, right? CUDA code. And this programming is called CUDA programming, right? Then the whole concept here is we can divide this work like this work one. We can give each of this work to the several cores. So this core, first part. Second work part can be given to the second core. Third one to third core. Likewise, we can divide work into chunk of parts and give into the separate GPUs. Separate core inside the same GPU. That is called CUDA programming. If you are interested, you can search, right? CUDA programming, right? CUDA programming. You can search what is CUDA programming, and there are syntax. You can do programming. Also, I am not much good with programming, right? How you can do programming? I am not a programmer. Especially the software technology students, they can focus on this programming, CUDA programming, how to program the CUDA GPU, NVIDIA GPU using CUDA programming. Also, there is another platform called OpenCL, right? OpenCL for this parallel programming. OpenCL, that's correct, right? Please check. I'm not much sure, right? OpenCL, right? OpenCL. OpenGP, right? OpenGP something, right? Research, right? This CUDA is correct, right? It is correct. It is correct. I'm sure about that one, that name. Right. That is about this performance. Parallel computing can be considered as a subset of distributed computing. Also, inside this distributed computing, we can do this parallel computing also, right? Right. Then, why distributed computing? Right? Why distributed computing? Right, nature of application, right? Sometimes we cannot do our work. Let's assume there are, I think, examples here, right? I will discuss, right? Then there are researchers are going about the astronomy, right? Astronomy, right? There are researchers are going. They are taking there are a lot of telescope, you know, Hubble telescope. There is number of telescope are available. From these telescopes, they are taking images and videos also, right? The size of this data is more than, I think, petabyte, right? More than few petabytes. The data that is collecting in one day from these telescopes, right? Right. There are in China. There is a large telescope. I know if you are interested in astronomy, you can find the telescope. If you search telescope, there will be a number of list of telescopes. But they are doing for analyzing purpose. They need huge processing power and huge memory to store these things. So they are using this kind of cloud computing. We will discuss, right? This kind of distributed systems. This kind of system to do this calculation, because normal servers or normal supercomputer cannot even perform this kind of calculations. So they are using this kind of distributed system all around the world, distributed computing system for this kind of calculation, right? That we will discuss, right? Then this performance, right? Computing intensive, right? Computing intensive, right? The task could consume a lot of time on computing. For example, computation of phi value, right? Using Monte Carlo simulation, right? computing intensive, right? If it is a huge computing, we need to use this distributed computing. As I mentioned earlier, this is some kind of example. Lot of time on computing, right? Normally for this astronomical case, it is taking huge time and huge power and huge computation to take final decision. Then sometime NASA will announce we will found another sun, another solar system, or whatever, black hole or something, right? So for finding these things, they are doing number of calculations using this kind of distributed system, right? In here, in this slide, there is example of computation of phi value. Phi value can be phi again, right? Phi value using Monte-Carlo simulation. This is some kind of probability value or some kind of model that can be used to calculate some kind of algorithm, right? Some algorithmic model, right? Not only algorithm, combination of algorithm, we can say that is some kind of model for calculation, right? This is some kind of using this Monte-Carlo simulation, calculate the phi value, right? You know phi value, 3.14, right? 3.14, right? To calculate this value, this is not, this is not a finite one. There is some kind of, this is not finishing value, right? Normally in our O-level calculation, we are taking 3.14. Not in O-level, in A-levels also, we are taking a lot of time. 3.14 is the value, as I remember, right? I am not sure, maybe I am not correct, right? Right, this is not a real value, right? This is some kind of nearly value, right? This is an infinite number, phi is, right? To calculate this phi value for, let's assume 1000 decimal points, we use this kind of algorithms, right? Monte-Carlo simulation, right? This is for that kind of calculation. If we have a distributed computing system, it is very easy to do this kind of calculation. Otherwise, number of days we have to calculate. Right? That is the case. And then data intensive, right? The tasks that deal with large size of files, like that astronomical case. If we have large files, terabyte, petabyte size of files to analyze, right? There is some example. Facebook, you know how many videos and how many images and how many content updates, maybe what we call your details, your bioinformation, they all are stored in this Facebook service, right? So it is some kind of huge intensive problem, right? Data intensive problem, right? Huge data they have to manage, right? And then this LHC, I think I don't whether sure you know about this one. It's a large hadron collider, right? It is some kind of nuclear energy testing system or the testing laboratory, we can say. It is some kind of collider, world largest and highest energy particle collider. Some kind of collider, right? It is using for the research purposes about nuclear power, right? In here, in this kind of researchers, they have to do number of thousands of calculations which cannot be done in a single computer. They need huge computing power. So in this kind of system, they are using this distributed computing. Right, experimental data processing, right? It is some kind of experiment, right? Right? This is experimental data processing. They need this kind of huge system, right? Then robustness, right? No SPOF, right? SPOF mean I think a single point of failure, right? We need to if we have a critical system like Facebook, YouTube, right? I think they are having very less downtime. Facebook, right? They have, I had noted that there is some few hours they are losing, right? Let's assume as a business, Facebook is a business name, how much of loss they have for that time that system was down, Facebook was down, how much of money lost for them for that hours. So that kind of system need to be high robustness, right? No single point of failure need to be happen, but they are still failing, right? They have some kind of downtimes also, but they are trying to mitigate, right? So this distributed computing concepts, and also we will discuss, right? Cloud computing also help for this single point of failure problems, right? Without any failure, we can run this kind of infrastructures, right? Then other nodes can execute the same task, right? Other nodes can execute the same task executed on failed node, right? If some node is failed to perform some calculation, right? Some calculation, then that calculation will be passed to the other nodes, right? That is, if this one is not, it is unsuccessful. It is not, if you are learning database management system or advanced database management system, we are calling as calculations, right? If there is calculation, right? It is committed to here. We are technically calling as committed to here. It is not successfully completed state, right? It is not successfully completed state. Then it will be passed to this second one. If maybe there may be some kind of programmatical or some kind of issue in this node. So that is the concept here. That will be passed to second, right? Then second will be performing, right? So this is the idea of this. Other node can execute the same task executed on failed node, right? If some task, if some task or work had been or calculation is failed in some kind of node, we can use other node for the calculation, right? Some few slide to go, right? But there is time is in a problem, right? Right. Okay. I think it is enough for today. We will now it is, I think, 2 hours, right? Nearly 2 hours, right? Continuously talking. I don't know if there anyone is available here, right? I think yes, you are available here. I think I'm going to wind up the session for today, right? If you have any question up to this point, you can ask. I will wait another 1 or 2 minutes for the question and answer session. Right, and there is a few announcement. Tomorrow, I think, according to your timetable, it is lectures is available. But tomorrow is a POE day. Already, I have some plans on that POE day, and also for the full-time students, according to your faculty, according to that instruction given to us, POE day will be a holiday for the full-time batch, but not for the part-time batch. Part-time batch only. If it is declared only, it will be holiday, but public holiday will be leave or the holiday for the full-time batch. So I think I will not conduct the tomorrow lecture, and that is some committed information to you. And I am about some kind. You have to complete some assignment for the continuous marks. I still not define what I have to go in, what I have to do, or what I will going to do for the continuous assessment. Then I have to discuss with your department and with your faculty, and I will decide what are the assignment that will be completed. Right, and I think this will be interesting lecture series, and we will hope to do some practical sessions also. And I think please participate for the lectures. And exam, if you have completely participated in the lecture series, that the exam will be very much easy, right? Otherwise, it will be some kind of difficulties you will face. If you have any questions, you can ask, right? To stop sharing, right? And right, then I think you don't have any problems or questions. Right, let's meet next week. Right, I am going to end the session. Right. Thank you very much for your participation. right? And okay,